Hello, everyone. Welcome to another episode of the Day Zero podcast. I'm Spectre, with me is Z. Today we have some topics featuring a maybe bug in Ruby's net HTTP package, hacking Google Drive integrations, DOM XSS puzzles, and some other stuff. So we'll start off with the contentious Ruby bug report. So this was reported in HackerOne. A researcher reported an HTTP header injection in Ruby's set content type method in the net HTTP package, which essentially takes a type and a dictionary as a parameter for key value pairs and inserts them into the content type header. The report states that the params parameter isn't sanitized at all, which could allow malicious input to alter the request through something like new line injection in the content type, showing a POC that'll set the content type to something that contains a new line to inject some arbitrary headers. Um, so,
Yeah,
like I said, there was a bit of contention here on whether or not this is a bug. So Z, I'll let you talk here.
yeah. So with this one, content type header oftentimes means just use say like content type, text HTML, or just the MIME type, but you can include some other attributes inside of it, like the character set. That's where this extra dictionary comes into play. It basically takes whatever attributes you give it and just assigns them right in there directly. The Ruby devs here took this report and basically said, this needs to be a sane value, so won't fix essentially. Uh, if you actually give this report a read, he does also talk about the string interpolation, but that's not happening here. Like, that's just a language feature. If you had a string with it, it wouldn't actually happen. So that was kind of a misleading bit in this report. But the fact that you can inject new lines, I could understand the developers going and saying, well, I mean, we just have to trust that the developers aren't going to put untrusted input into this dictionary. And in fairness, I struggle to really come up with a scenario where this is going to be exploitable. Um, Actually, the only attribute I could really think getting added to the content type, I'm sure there's other things you can do with it, is that character set attribute. And I can't think of a good reason why you're going to just let the user specify the response type like that. I mean, maybe with some user upload files, it grabs it somehow or tries to figure out or something, and you can get it there. But it is a very weird scenario where you're going to have user controlled data coming into this, and this is just in the Ruby library. So any application using this, if they sanity check, they're using static values, there's no issue. It's only if you're able to get user controlled data into this particular area. I would still argue, though, that on Ruby's side, there's no reason they should even allow injecting a new line into that. Like your character set, like you shouldn't, when you're setting the content type, I do feel like they shouldn't even let the developers shoot themselves in the foot by letting them inject extra headers through the content type. Like it does feel like a bug. Maybe it's not actually going to be exploitable. Maybe it will be. It really depends on the context of an application using it. It just feels like one of those things that it's there, and now when you're kind of aware of it, I kind of wanted to show just for anybody who's doing like the bug bounties, if you run into this scenario, it's like, what can I try here? Ruby does let you do this, so it's at least worth being aware of the fact that they decided not to fix this because it probably will bite someone eventually, or maybe already has, but yeah, I don't know. I mean, I could understand developers not really caring to fix it because it's a fairly trusted input. I just don't see a good reason not to fix it either.
It would be a quick fix, so I kind of agree there. But it does really come down to that idea of trusted and untrusted input. Like, I mean, I would classify this as more of a sink than a bug. If you can have untrusted input reach this function, then yes, it is dangerous, and that would be a bug. But you kind of have to prove that, in my opinion. Like when you submit a bug report and say this is a serious issue, you have to be able to prove that an attacker could actually take control over that data. And yeah, I just don't see how you would ever give an attacker control over like a character set or anything going in the content type.
I don't
So
entirely agree with you there. So
okay.
here's where I'd kind of say that, like, this is a library. This is used by other applications. There's no application that's using this just in isolation, nothing else wrapped around it. So I don't think it needs to be on the developers to go and say, yeah, this random application is using your library in a vulnerable way, but rather the library itself allows this vulnerability to exist. If they like, I know where you're coming from and say, they need to show actual damage, but we've reported on other cases like, do you remember the Symfony bug where I think it was the exported host header was being parsed in one area but not in another? Um,
It rings a bell, yeah.
yeah, they had an issue where basically even if exported host wasn't a trusted header, it would still actually get used and routed upon later. And you didn't have to show that some application was actually using that and could become vulnerable to cache poisoning. It was enough that the library itself enabled the vulnerability to happen in the first place. And I kind of think that's how we should treat the libraries is, does the library allow you to kind of shoot yourself in the foot and do this fairly surprising thing? Like, yes, if I give it a new line, I would argue that it should have, well, I I would argue perhaps it should either return an error like an invalid data type, do that sort of checking, or strip characters like that, because there is no reason to actually have a new line in there in the first place.
So while I would
Um,
agree in this specific case, it would be an easy fix and it'd be easy to make it safe. My problem with that idea of it being a library so we can treat it as a bug and not care too much about the data coming in is like, how far do you take that? Because there's lots of libraries with lots of methods that'll do dangerous things, and it's up to the person using that library to sanitize any input going to it. So I kind of feel like it depends on where you pin the responsibility, I guess, when you're calling this function. It could be fair, like even if they didn't fix this, they probably should point out in the documentation that this is a possibility or have like a warning. I would kind of agree with that, but at the same time, if you're allowing, like, you should be doing filtering on any input that would be going to setting something as crucial as like content header information anyway. So yeah, I don't know. I guess I could kind of see it both ways. Uh, in this specific case, yes, it would be an easy bug to fix, but at the same time, I can kind of understand the Ruby staff not really wanting to treat this as a vulnerability and closing it as informative. I think that's a fair path to take as well.
I mean, it's definitely like their decision to do that. Like as a project, I don't necessarily think like, hate on Ruby because they chose to do that, because it is a fairly minor thing. And it is something that I struggle to really see a lot of scenarios where this would happen, especially because this isn't a response content type header. This is the request going out, like it's in the client, which again makes a weird place to have an issue. At the same time, when it comes to how far do you actually take it, that's a good question. It does give me pause. Like how far when it comes to those bugs, but I don't know. I feel like something like set content type, you expect it to only set the content type, not be able to add extra headers. So it just kind of violates, in my mind, it violates the idea of like the law of non-surprise, where the function shouldn't be capable of doing something surprising. That said, I think that's also a stretch to apply, the law of non-surprise to this, when it's a malicious input. But I feel like, when you have something that will do like an exec or eval, you kind of understand there's the security implications there. Documenting it, I think, would be a fair, as you put, a fair option. Making it known that there is this risk here, that this input does need to be sanitized. I don't know, it's an interesting scenario. I've seen similar things kind of reported, again, not. Usually it's in more of a response and in the client library, so it is weird on that front. But I have seen similar things reported elsewhere also.
Like you said, though, all in all, an interesting report because it's one of those situations where nobody's really wrong. Um, all parties, like the researcher and the vendor, are kind of right in their own ways. It's just, yeah, it's a weird scenario where it's hard to come to a consensus. So yeah.
Yeah, like I mean, as long as Ruby's consistent, I don't really think they're necessarily wrong to close it. I just think they should. I don't know. I think it should be dealt with because it is an easy thing, but yeah. I mean, you can stand on both sides of this issue, I think, pretty reasonably.
Yeah, for sure. All right, so we'll move into our next topic here, which is a bug in the NIM standard library used by NIMform due to, well, kind of a misconfiguration type issue, I guess, in the RSTGen package. So, as a bit of background here, NIMform supports restructured text for posts, which is a very powerful text processor compared to something like BB code, which is a lot more common. BB code and Markdown are kind of your most common two, but they use restructured text. And restructured text supports some very powerful capabilities um, or directives like include, which can include files in the output. As such, it's dangerous to allow, and the RST to HTML function in their RSTGen package tries to use a myFindFile procedure that effectively does nothing, and the docstring outright states that RST include like directives won't work. But when the researcher, being NNSCE, actually tried this and tried to use includes, it did end up working. Now, the reasoning for this wasn't totally clear. When I first read it, I thought it was because later on in the post they mentioned that there's a extended code block directive in the RSTGen package, so that like even if they went through the work of blocking includes that still would have allowed using or including files to the file field. But that's kind of something they point out after the fact. That doesn't seem to be the actual root cause of includes working here. And Z, you kind of have a theory on what's going on here, so I'll let you talk about it.
Yeah, and it is a little bit unclear as to why the include work. But the actual reason I wanted to include this week was largely because of the fact that they're misleading comments in general. To answer this specific point, though, my kind of theory there is more that this initial comment, this proc is meant to be used in online environments without access to a meaningful file system. Therefore, RST include like directives won't work. My thought is I naturally, in the at least in this context, I want to read that as descriptive. This procedure, basically you're supposed to use this in online environments and it won't do like include in those directives. But it might be more of a prescriptive thing. You should only use this when you're in a restricted environment that doesn't have a meaningful file system, and therefore include fails because you don't have the file system for that. Um, that's kind of my feeling is that it might have been more of a prescriptive thing describing where you should use it rather than descriptive saying how it runs. Um, that maybe is a bit of a stretch. It is a weird scenario, but I think it's just important that test assumptions. Don't assume that all of the comments are right because it could be the case that this comment was true at one point and then was no longer true at some latter point. They do have the myFindFile, and I didn't look at the source code. It's a really weird name, and I wouldn't be surprised if what ended up happening was this was just never attached to like replace the include directive or something. Because myFindFile, it honestly reads like somebody was following a tutorial. It's
It
like,
does.
my string, myFindFile. I don't know. It reads like that might not even be a real function that gets used, to be honest.
I do have a bit of a counterpoint to your idea of it being like not descriptive and being prescriptive. The reasoning is just that last part where it says, therefore, RST include like directives won't work. Focusing in on that won't word, it seems very definitive in saying like it's not going to work if you do this, which is what kind of makes me think that it's more descriptive. But
Well, and I agree with you. I do think this reads more descriptive than prescriptive, but I could interpret this to be saying that, those online environments, if you don't have access to a meaningful file system, then include wouldn't work. Like if there were no file system attached or no meaningful file system attached, so you're using this in a sandbox environment like you might do with like a REPL or something that's executing code, you spin up a isolated environment that has essentially no file system. You execute that code, don't even give it network, execute that code and get the output. I can kind of see it as being like that, where you just don't have a meaningful file system, and therefore include isn't a worry. But I agree with you; it does read more descriptive. I'm just trying to, you know, be optimistic, I guess.
Yeah. So, like you said, it mainly comes down to testing your assumptions. Really, that's what happened here. Is just if you just do like a if you're just doing a quick code audit and you see like okay, it's include directives won't work. It's easy to just take that assumption at face value and keep going. Whereas, yeah, if you actually test it, that's not the case. So,
Yeah,
for
and
what it's worth,
that
they
is.
oh
Oh, I was going to say, like, that is kind of an important thing to keep in mind. I've often run to those cases where comments just end up out of date. They might have been true at one point, maybe they were never true, but you really can't trust them. But it is so easy to think, like, oh, they've done this legwork of explaining how this thing works to me, and I don't have to worry about it. And it's just not always true. So this is a reminder of that, I suppose, too.
yeah, it's very easy for you to trick yourself into thinking like when you see a heavily commented area and it's like okay, someone's read this and reasoned about this, um, so I'll move on to somewhere else or something.
It's
Yeah.
also warning somebody thought it was worth documenting something here, that it wasn't self explanatory.
Yeah. For what it's worth, they do detail what fixed this a little bit in the mitigation section. They link to the commit. The fix here was basically additional sandboxing. They don't go too much into detail about that. You can go to the commit and read the code if you're interested. But it seems they do some sandboxing on the directives themselves. So um, that's kind of what's going on there. All right, so our next topic is a deserialization type issue in HigherLogic community, which is like a software as a service platform, which is based on .NET. The blog post here is by a pen testing firm by the name of Sorcery. As you can guess, with it being .NET, there's a focus on deserialization here, and the main area of focus is the view state parameter, which is used to store all the information related to a user session state, so their settings, their identification, things like that. And it's a very large object that has to be sent with every request from the user, which isn't really ideal because, well, yeah, it slows things down when you have to send something so large, and that kind of contributes to why this issue is even an issue.
Yeah,
But
and
yeah,
I'll add on there, like, view state itself. This issue here in deserialization with it, just modifying it in general has been a like default protected thing, and I think this comes out of .NET MVC. I think that's where you tend to see this. Somebody might correct me on that, but I believe that's the framework that comes out of. Maybe it was just default .NET stuff, but it's been a resolved issue for a long time. Just don't allow users to tamper with it. Include a little like HMAC, a signature, something on there just to say like if this signature doesn't match anymore, if the data's changed, the hash doesn't match, this is wrong. Don't trust it anymore. Oh, I'll let you go on to where the issue came up though, Spectre.
yeah. So where the object is so large, obviously it makes for a pretty large attack surface for deserialization type issues. And as such, along with some of the things that Z mentioned for protecting view state, the view state, some of the wrappers had some updating, so that, yeah, you would encrypt the settings with like a private key, so that settings couldn't be attacked to exploit deserialization issues. And there were also some other mitigations that would try to minimize the attack surface there at least. Well, it turns out that because this object was so large, an alternative view state called vstate was used by some developers, which was the view state that was compressible so that requests could be shrunk down a little bit. I think they used gzip to compress them. And as you can guess, this vstate variant didn't receive the same updates that viewstate did. And higher logic community uses vstate. So all of that work that went into the past years was basically forgotten and lost. So these kind of older attack strategies of attacking the view state were reborn, and they were able to find and exploit a deserialization bug using a payload generated with YSO serial, which is a common deserialization payload generator for .NET. We've seen it before in other reports. So yeah, I mean, basically just a case of a variant that branched off because of different problems that developers were having, and yeah, it breathed life into older attack vectors, I guess is how I'd phrase it. Um, and just taking this state information that is technically untrusted, but it's being treated almost as if it's trusted data, which is kind of why that signing or private encryption is such an effective mitigation. But yeah, it's just a bit of a weird scenario, I guess, with untrusted and trusted data being kind of mixed in the same blob. So
I mean, part of it definitely has to do just with history. Just the age of view state, like that comes and has been used, I'm pretty sure, for decades at this point. Like there weren't a lot of standard ways of like, having this view state information, shared and persisted across requests. And, that was how .NET kind of did it in the early days. And it does feel a little bit like it's just an aging thing that's still there. And so things just kind of get added on, vulnerabilities are realized. Like nobody was talking about deserialization vulnerabilities in the 90s. At least as far as I'm aware. I don't remember it at all. It is it is more recent than that. Obviously this also got fixed or resolved with the integrity checking. And yeah, encrypting it was one way, and I believe the other way is just including like a signature, hashing it with some secret value. Um, many many years ago. So it was just surprising to kind of see it pop up here again. Um and it does look like they had a little bit of a hard time when it comes to actually reporting this issue also. Submitted to
yeah,
ZDI,
very
who
interesting
rejected
reporting
it,
process.
but tried to email HigherLogic to get this resolved. Asking, for a response, called their phone number, ended up reporting this to various places that were actually running it, 8x8, IBM. Um, then finally ends up getting a response from other places. Eventually, this did get patched. They ended up getting a $1,250 bounty from an unnamed company. But yeah, I mean, I'm hoping it was patched in the actual HigherLogic. I don't know if they actually call that out, but they do mention here that in December, ConnectWise site was patched by HigherLogic, so presumably it was.
Yeah, so like they tried doing initial contact with HigherLogic multiple times. It seems after they submitted to some of their customers, like 8B8 and IBM, ITO security at HigherLogic reached out asking for vulnerability details, which they did send over, and then it was like radio silence again. They seemingly never heard from them again. So, and yeah, 8x8 and IBM was patched by HigherLogic, but there didn't seem to be any indication of sending out like any updates or notice for other customers. Um, though eventually
Interesting. I just read this now and want to call it out. I guess he asked 8x8 if they can ask HigherLogic to inform their other customers. 8x8 informed him that HigherLogic did not address the concerns.
yeah. So for whatever reason, they didn't want to put out an advisory to other customers. Though it did seem that other customers did get fixed because later on they say, um, I think they said like 1,700 websites or so would have been affected by this, and they were eventually patched in the middle of January. So that's why they're disclosed now. But there is that gap where there was not really any information being put out by HigherLogic, and then it was just fixed all of a sudden. But yeah, I don't know. Kind of hard to
At
tell
least it
because
was
we're on the
fixed.
outside. This is kind of an enterprise thing, but yeah, like you said, it was fixed. But one of the more interesting timelines we've seen from bug reports. It's been a while since we've seen such a weird back and forth. So
Yeah. Well, not even back and forth.
yeah, broken back and forth, back and
Yeah.
back channeling, I guess, with customers and stuff. So. Right. Getting into some XSS stuff, we have two post message based XSS phones in unnamed products that had interesting exploit scenarios that were detailed by Space Raccoon. Z, I'll let you take this one.
Yeah, and I think only one of these are actually in the post message. This first one here uses the post message. The second one is just a internal request, like HTTP requests being made, getting data. Anyway, I'll jump through these. I did think, so I will also shout out this is a post if you want to give it a read to get more of the thought process on how we kind of connected all the dots, because that is kind of what's interesting with these posts is more connecting the dots, or as he puts it, solving these puzzles to ultimately kind of get a more serious vulnerability from where he started. And so this first one, and these happened on private bug bounty programs, so we don't know the name of the application that was being tested. So he tends to refer to them as like company A, company B. I'll probably just say company as I run through these. First one here was noticed a post message that didn't do any origin checks. So that means any sort of place that frames it or has an iframe loaded by it. Basically, anybody can go ahead and send a message to this frame. It's going to get that message, process it, and do something with it. It doesn't actually care where it comes from. Ideally, any post message you should be doing origin checking. There are some reasons not to, but ideally, like, it's definitely a sign when something doesn't, because that means an attacker can frame the website and send post messages and interact with this when they're usually not going to expect that to be malicious content. So we're starting off with this message event that does a if e data type, so the event itself, data.type, so the data you control. If you set the data type to chat settings, you can do one simple thing. It just takes this iframe chat settings and sets it on this Windows settings sync value. That's all it does. So on its own, not really a vulnerability. You can maybe change some settings going by the name of it. Next step was figuring out, well, how does this get used? What's going to be done with this? Is there anything in that settings sync that you might be able to abuse? Which again is where he found that there is this one value, the region in it, that is used to craft a domain. Basically just reads out or tries to read out a region from it and figure out what subdomain it should try and get settings from, and then it does. It feels like this is sort of like a refresh settings type of feature. I'm not exactly sure what the intent is here. But the idea is it'll figure out what region you're in, generate the subdomain to request, makes a request onto that subdomain, reads the JSON back from it, and replaces the entire setting sync value with the data that it read back. And then gets the version from that and loads a script reflecting that version just out of the CDN. So it feels like sort of a refresh, update sort of feature to me, but we don't have a proper name for it, so that's just kind of my hunch on it. So the issue there ends up being the way it processes that subdomain is if you end up creating basically a malicious region value, you can have it craft a domain that, well, it'll think is going to this .settingsync.com, is actually going to go to some malicious website. So he ends up using where's his example here? Yeah, like DOM my website / malicious PHP underscore whatever region. Effectively, that underscore ends up getting it. Basically, it ends up thinking that when it appends that .setting sync at the end, that is actually part of the query path rather than the domain. Yeah, he included a question mark in there as part of the processing. It gets processed poorly. You can look at the code if you're actually interested in the specifics on that. But that gives them control over the domain that it pulls out the settings yet again from. So that is kind of the other interesting part about this is we already have this initial chat settings thing that lets you control the Windows settings sync value. And then down in this case, he has this other one here with the domain, where we're saying that domain, and it's again only giving them control of that Windows settings sync, but it's what happens after that where things are a little bit more interesting. It then uses the version out of that, and it has to come out of that JSON it just loaded. It thinks it's trusted. Needs to grab that version number, loads a version JavaScript based off of that, and actually just does a load script with that. You might want to jump at that as being, well, there's your XSS and just point that, but this one, because it is just applying that into the .js, does seem like you couldn't quite escape that to have it just load any arbitrary script. I think there was also cores on this one that was running into a problem. Maybe not. No, that was the next
I don't
one.
remember
Sorry.
cores being a problem. Yeah.
Yeah, that was the next one. So yeah, with this one though, basically this JavaScript that did get loaded from based on that version number, found one here that would basically just read the config value and do a eval using that config value. Ultimately, that eval in the hosted JavaScript is where they were able to get execution, at least some JavaScript execution. Problem being that that is on this CloudFront domain that's just being hosted by the CDN. Load that script. It's basically sandboxed off. Benefit here though is that
Well, it's
there
in
was
it's in an iframe, so
well,
yeah.
yeah, it is sandbox off. Like ideally, you'd want to have this. So this is all happening in, as he puts it, feedback.companyaa.com. So ideally, you want accessing companyaa.com within that kind of domain context rather than inside the iframe. Because from inside the iframe, you can make requests, to CloudFront, but you can't make requests back to feedback.companyaa.com. Yeah. It's in a different context. So ideally, you'd want to be on that feedback context or inside of the original application context. So what was noticed, though, is there's yet another post message, this one that does do origin checking, but it trusts the CloudFront origin, which you can then use, send this iframe loaded message to it, message type to it, and it would send back credentials or the credential configuration, which included session tokens, then creating the aspect for actually hijacking an account. So I thought this one was kind of interesting just in terms of all the chaining of issues there. A bunch of little things, just like that little compromise at the start. Keep working with it, finding other gadgets basically out of it, building up to account hijacking in theory once you have those session tokens. The second issue here is just bypassing the CSP or content security policy with a new line open redirect. Little bit interesting on this one too. They had a kind of OAuth type of flow going on where this company B page this time will have the request come in, confirmation, has a domain, has the state, has the client ID, kind of some of the usual things that you would see with especially the state client ID, some of the usual things you would see with an OAuth request going to that authorization page. Once it loaded, though, it would do a GET request to an OAuth data endpoint with the client ID, and that would fill in kind of the provider information. Things like the logo, URL, name, link, and kind of importantly, the introduction. They were able to get pretty straightforward cross-site scripting just through controlling whatever's in that introduction. And one of the parameters that is getting passed in is this domain. So they control the domain. It basically goes to try and find the OAuth provider's data from just by providing it there and say, hey, yeah, load this from here. But they were more restricted this time by the content security policy. This time you had the main thing was that GET requests were limited to either company B or Amazon AWS.com. So effectively, actually, I mean, companyb.com would be a fairly effective CSP. Having Amazon AWS as your restriction, though, that includes S3. Upload anything into an S3 bucket, and you can just host it there instead, which is what they ended up doing there for their initial issue, was just hosting their attack through S3 so that they're on a valid. I mean, the next issue was that your script source is limited to either self or company B. So the way they end up getting through that one was just using an open redirect on company B, which on its own, the redirect itself is at least a little bit of an interesting case. It takes advantage of the fact that the browser will how the browser will treat something. Basically, it would, for the redirect URL, which just had the classic redirect type endpoint takes a URL, it would validate and make sure that URL ended with companyb.com, trying to ensure that you can't do too much or can't redirect just anywhere. Problem with that ended up being that if in the domain you included a encoded new line character %0a, then the browser, when it sees that and tries to redirect, if you have like a location header redirect to this URL, the browser is going to treat that as the end of the domain and the start of the path, so that 0a is going to end up as a new line and part of the path itself. So he shows the example here of using like http evil.com 0a.companyb.com as like a valid URL. Ends up ultimately redirecting to the malicious evil.com website, which can be attacker controlled, giving ultimately cross-site scripting again. So yeah, just some kind of complicated chains here, a lot of steps to go through. Hopefully you're able to follow that. Talks through a lot more of his thought process on how he connected the chains through the post. That is kind of interesting if you want to check it out. But the issues themselves, it's just a good example of how, sometimes these issues just need to get chained a little bit to actually create a more impactful issue, I guess.
Yeah, a lot of the time when we see XSS, it's kind of like a one and done type thing where it's like, I found it, it works, here's the exploit, and patch it or whatever. Whereas in this case, getting that initial XSS to do something useful is a bit of a process and takes some extra steps. So, yeah, I mean, this is something that you could reference if you find yourself in kind of a similar scenario in some other type of assessment too. So, yeah, there's some good thoughts in here, I think.
Yeah, I mean, I don't know how much you'd really be able to copy right out of this because everything is kind of specific to this application. But the idea is of needing to look through and finding, other post message things. Like, initially you might scan through and look for all the post messages you can hit without being trusted. But once you have that other origin cross-site scripting, you have to remember, go look back and see what you can hit now. How have things changed since? So might not be able to copy the exact techniques, but I don't know. It's one of those kind of stories. I like reading these just as like, if I'm stuck, get some inspiration, something might stick.
Exactly. That's what I was gonna say. Was I think it's a good post for inspiration. So yeah, we'll move into our last post here, which is Google Drive integrations from Harsh and HTTP Void, and details a bit of a weird quirk with the alt equals media system parameter in Google's REST API that could be abused on applications that integrate with Drive that aren't aware of that parameter or don't account for it at all. And it's based on the idea that when you're downloading a file from Google Drive, in the request URL, you include information like the file ID and the access token necessary to access that file through the fetch endpoint. And so an application might take a user controllable ID to construct that request to download the file. Now, usually the response for that request will contain metadata, which the application will then parse to get the proper download URL and whatever else they need. But if you specify this alt equals media parameter, that response has changed from being a metadata like response to be the actual file contents, which if you can get the application to parse the file contents as if it were metadata and stick that query in there, you can get a sort of type confusion um, where if you control the file contents, you can control the metadata essentially, um, and that the important piece of metadata there being the download URL that gets parsed, which effectively gives you an SSRF. This was found and abused on two case studies documented in the write up. The first was in a private bounty programs application. It was a partial read SSRF. Interestingly, in this case, they weren't immediately able to get control over the query parameters through the ID. They don't really say why, but I'm guessing there's just some filtering that's not really shown.
Well,
Um,
I believe the reason why was because it wasn't using it might have been accessing the API. Sorry, I thought I remembered it as using a post request for it, but as I was looking at here, I do see that that was part of uh the front end's API, not the back end to Google. So I was mistaken there before I made the claim.
yeah, all good. So, yeah, like they don't really go into too many details there, but like I said, I'm guessing it's just some filtering that's going on. But they were able to inject new lines into the auth token, which gets used in request headers. So by gaining control over the request headers, they could create a GET request to that file with the alt equals media parameter. The reason this was a partial read is because the file is parsed as a PPTX. So I'm guessing whatever this application was doing, it was doing something in with like Google Slides or whatever. Um, so yeah, you're kind of limited based on the file format there. The second bug was not as well documented, but it was in Dropbox's Hello Sign. Um, Basically, no details though, unfortunately, on that one because, well, I'm not really sure. It's a little weird because the private bounty program where it was anonymous, we got more details, and the Hello Sign we don't really have any.
Well,
But it's worth calling out that there was an issue there.
it feels like to me part of the reason there, if you go to the HackerOne report, basically indicates fortunately HackerOne's being a little bit slow and failed to load for me here actually. There we go. Um it basically indicates here that by making use of an extra parameter, so it had a URL parsing issue that could allow extra parameters to be passed. By making use of the extra param, they were able to force it to parse the external data. So effectively, that sounds like this is the traditional case that he or the author explored as the first post, or as like the first part of the post. Just they could inject the file ID straight into, putting the ampersand and doing alt equals media right in there. Like that's what it sounds like to me. Is it was just a straightforward escape the one parameter, inject another one, and away you go. At least that's what I got out of the summary, was that it's probably just kind of the classic case. And that second one he went in, or sorry, the first case study, the partial read, we got more information on because it was a little bit more unique, using the double new line injection to basically create a new GET request that would then get a response.
Yeah, so maybe the one in Dropbox or Hello Sign was just not as difficult of an exploit, more straightforward, so that they didn't want to reiterate over that. That's
And
fair. That's
as a
probably
bug, like it's interesting because this is kind of an escalation from a usually fairly minor issue of parameter injection. Just like you can include these extra parameters into a fairly serious SSRF situation. Of course, it's going to depend on the scenario, what the application is that you're able to inject parameters in. But it's definitely an interesting case to keep in mind. I haven't run across it a lot myself, but it's something that I would probably be more aware of now, having kind of seen it being pulled off here. Um, yeah, it's just an interesting attack. And I also want to shout out really small thing here, but I noticed that so he talks about adding this SSRF header that's just used by his server to do like a redirection, just something to help him with testing basically. But I noticed his URL here was rce.ee, and I just like that. I like that domain name.
unfortunate that you can't get it now.
Well, I can't get it now, but it's a nice
Yep,
domain name. I just wanted to shout it out for that.
fair enough. But yeah, unless you have anything else you want to add on this topic, I guess we'll go ahead and move up the show, or wrap up the show, I should say.
Nope.
All right, cool. So that's where we'll end the show for today. As always, thank you to everyone who tuned in. The VOD will be up on YouTube and Spotify and whatnot tomorrow, up on Twitch immediately. Feel free to check out our Discord or follow us on Twitter for when we go live or for any discussion. Links for those are down below or in the chat. Tomorrow, we'll be back with our binary episode. That's at 7 p.m. Eastern, 4 p.m. Pacific, and we'll see you all then.